Good morning. This is Ms. Billerbeck, and we're going to talk about 3.2 special products of algebraic expressions. So if I have the quantity a plus b squared, if I FOILed that out and combined my like terms, I'd have a squared, then I'd have two ab's, so two ab's plus a b squared. Now, if the sign was different, if it was a minus b quantity squared, then I'd end up a squared minus 2ab plus b squared. And then if I had a plus b times the quantity a minus b, well, the middle term cancels out, and I have a squared minus b squared. So these are called special products, okay? So we'll do a few examples so you understand how this becomes a 2ab in both these cases. And how that becomes a positive sign even though that's a negative, and how the middle term drops out. So our first one, if we were to expand using FOIL, so 4t, and this says using the special products, it's 4t squared plus, and then this is 2 times AB. So if this is A and this is B, so 2AB would be 2 times 4T times 1. And then this would be B squared, so 1 squared. So if we just blindly use the formula and do this, we end up getting 16t squared, and then 2 times 4 times 1 is 8, so plus 8t plus 1. Okay, so if we had FOILed this out, 4t plus 1 times 4t plus 1, we would have gotten 4t squared for our first, outer plus 4t, inner is plus 4t, and last is plus 1. So if you see, there's 2 of these 4t terms, which is why there's 2 here times 4t. So this works in a perfect square trinomial. So that's a name for that. It's a perfect square trinomial is what we end up with here. So trinomial means 3 numbers. So tri means 3, nomial means numbers. Okay, so if we use the special product for this blindly without expanding like this, then this is going to be my A, this is going to be my B. So I'm going to have 3x, and the whole thing's squared, plus 2, and then I'm going to have A is 3x, B is 2y, and then the last term is b squared. So I have 2y squared. So if I take this exponent and distribute it to both, 3 squared is 9x squared, plus, and then I have 2 times 3 is 6. 6 times 2 is 12, xy. And then again, I'm distributing to both of those. So 2 squared is 4y squared. So that's how we would use perfect square trinomial formulas. Okay, so you just blindly use that formula and plug it in. Okay, if you're not sure about how to do this, then you use the box method that I showed you. You know, where you just do the box like this, and you put the 3x plus 2y here, 3x plus 2y, and you end up with 9x squared, 6xy. This is going to be a 6xy and 4y squared. And then we have like terms right here, which end up being 12. So you could do that as well. All right, so if we just blindly do the formula where this is A and this is B, we note that there's a minus sign there, so it's 6 squared plus, whoops, that's a minus sign, so we do a minus right here, 2 times 6 times n, and the last one's a plus n squared. Okay, so that's 36 minus, and 2 times 6 is 12n plus n squared. So that's what we would have. If we had done a quick box method, let me erase these two. 6 minus n, 6 minus n, and that's 36 minus 6n minus 6n, and then plus n squared. So that's exactly what we got because we have like terms on the diagonal. So there we have it. Okay, so this is going to be our A. This is going to be our B. So we have 8c squared minus 2 times A, 8c, times 3d plus 3d squared. So this is going to give us, if we distribute that exponent, 8 squared, 64c squared minus 2 times 8 is 16. 16 times 3 is 48. And then we have CD. If you didn't like doing it that way, you could do 8 times 3 is 24. 24 times 2 is also 48. Okay, this one we distribute that to both. So 3 squared is 9, and then we have d squared. All right, this last one we have A, and this one is B. So we're going to have 7st squared minus 2 times 7st, which is A, times B, which is -1, so don't forget, oh wait, we already took into account that negative, so it is 1. Okay, and then plus 1 squared. Okay, so that was kind of important, this one, because I really wanted to put the negative there, but the formula puts it right there. So just call that a positive number with a minus sign in front of it. Okay, so we distribute squared t squared. This one, 2 times 7 is minus 14, and then just st, and 1 doesn't do anything, 1 just keeps it that. And then 1 squared is just 1, so that would be our answer down here. Okay, so we have some very complicated answers, but if we use the formula, that was pretty quick for such complicated expansions. All right, when we have this, we have different signs. So whoops, wrong one. So next lesson. So if we have different signs, we get a squared minus b squared. I just showed you the one from the next lesson. Don't want to scare you. So this one we're going to just say, okay, so it's just going to be q squared minus 6 squared. And that's q squared minus 36. Now, if we had FOILed this out, let me just show you with the box what happens here. It's really visible when you use the box. plus minus 6, and q plus 6. Okay, so we have q squared, we have minus 6q right there, and this is a plus 6q, and then we have minus 36. So the plus 6q and the minus 6q, those two cancel out, and it's 0. So that's why there's no middle term there. So if this is A on this, and this is B on this, knowing that that middle term is going to cancel out because they have alternating signs, then we can just say 11u squared minus 5v squared, and that's going to be 11 squared is 121 u squared minus 5 squared is 25 v squared. Okay, so those are our answers for that one. Now, if we're going to use special products, we can use those to evaluate numerical expressions. So on this one, I can say, hey, let's do 200 minus 2 squared, and let's use that formula. So that's 200 squared minus 2 times 200 times 2, and then plus 2 squared. Okay, so 200 squared is just 2 squared is 4, and then we have 4 zeros. Because if you're squaring 2 zeros, that makes it 4. Then this one's negative 400 times 2 is negative 800 plus 4. So if we add this all together, this is going to equal 40,804. Okay, let's just do a quick check to see if that worked. So 198, 198, not very pleasant. So we have 64, that's 72, 78. And that gives me 8 plus 7 is 15. We take a spot right there. We have 72. Again, so now we have 72. 81 plus 7 is 88. And then that gives us 17. Now we have 2 spots. We're multiplying by 100. So we have 8, 9, 1. So let's see what we get. Does not look like it's going to be the same though. So we have 4, 10, 16, 22, and then 10, 19. So we have 39. Oh, that's because I didn't minus. Oh, so let's do that. Silly me, I added the 800. That's why it didn't look the same. Okay, so these two we can add together. So 404. Well, let's just subtract. I bet you said that on your side. Wait, Miss Billerbeck, you are adding 800. Okay, so when we subtract, we get 0, 0. This becomes a 3, 9, and then we get a 2, and then we have 0, 9, 3. Okay, whoops, too many zeros. Okay, and now we're going to add 4. So this is going to actually equal 39,204, which is what we got right here. Okay, so good thing I checked. Okay, so let's, so be careful with the signs. Moral of the story. You know how we all make mistakes, so that's why we don't use pen. or we use dry erase pencils that can be erased or pencil. Dry erase pens or pencils. Okay, so there we have it. That would be how we do this one. This one we can write, let's do 30 plus 0.5 and square it. So that becomes 30 squared plus 2 times 30 plus 0.5, and then plus 0.5 squared. So 30 squared, 3 squared is 9, and then we have 2 zeros because we're 1 0 and we're squaring. This is 2 times 3, which is 60, but then we're multiplying by 0.5, which is the same thing as a half. So that gives us 30, and 0.5 squared is 0.25. So the answer for this one is 930.25. Okay, so if we double check that, let me do that really quickly on the calculator, make sure everything is good. And that's exactly the right answer. All right, this one, it looks a little hard, but it's actually super easy. Okay, so this one we can rearrange as 100 minus 1 and 100 plus 1. Then we know that this is 100 squared minus 1 squared. So that ends up being 10,000 because we want 4 zeros because we're squaring 2 zeros minus 1. So we end up with 9,999. Okay, so there we have it. 99 times 101 is 9,999. And we just used our special products to find that. All right, you have a wonderful day. Bye-bye.